So, electrolysis with combined sciences, you need to know just molten. You don't need to know what happens in aqueous. Triple science you do. So let's break that down. In combined sciences, first of all, and I guess just both sciences, electrolysis, you need to know what it does. It's basically decomposing the ionic compound using electricity. So if you have NaCl, for example, that ionic compound is going to decompose. It's going to go Na ions, and then Cl ions. And they split this up using electricity. The cathode, the positive electrode, the negative electrode, and it gains positive ions. So essentially, the cathode is the negative electrode. Positive ions are going to go to this negative electrode because positive goes to negative, and is going to gain electrons. These are called reductions. At the anode, negative ions are going to go to the anode, the positive electrode, and it's going to lose electrons. This is oxidation. I know this is confusing. Use a mnemonic oil rig. Oil, oxidation is loss, rig, reduction is gain. So oxidation is loss of electrons, reduction is gain of electrons. And negative ions are losing electrons to form these compounds, and then positive ions are gaining electrons to form these compounds. So if I have a bunch of Na that's going all the way to the cathode, it's going to gain electrons to form sodium. Same with chloride ions. It's going to go to the anode. It's going to react together, form chlorine as it loses electrons. The half equations are usually represented. Triple sciences, they heavily ask you on writing half equations. You combine sciences too, but more on triple. Yeah, that is kind of the gist of it. With molten compounds, it's very simple because molten compounds, there's only two ions in it. It's just going to be the sodium and it's just going to be the chloride. I'm just using sodium chloride as an example, but it's just going to be the two ions you have in there, the positive and negative ion. So if you have a molten ionic compound in electrolysis, you're just going to produce those two things. The metal is going to be at the cathode. The non-metal is going to be at the anode. It's simple as that. Nothing more to explain. That's all combined sciences kind of need to know regarding electrolysis. I know there's a few little extra details, but that's kind of the basics of it. For triple sciences, this is where this is very, very difficult because it talks about aqueous solutions. Reason it's so complicated is because aqueous solutions, not only does it have the positive and negative ion, it also has water, meaning it also has OH minus and H plus in it. So let's break it down on what would happen. Okay, this is why you need to understand the reactivity series. At the cathode, where the metal is usually produced, if the metal is more reactive than hydrogen, so the H in this case, if the metal is more reactive than the hydrogen, hydrogen will be produced instead, not the metal. So let me say that again. At the negative electrode, in aqueous solutions, when there are both positive and negative ions from the ionic compound, you still have H plus and OH from the water from aqueous solution. Because the metal is more reactive than the hydrogen, the H pluses are going to react, and they're going to form H2 instead of the metal. So anything that is below hydrogen in the reactivity series is going to produce the metal. Anything above is just going to produce hydrogen. Okay, now for the anode. The anode, because of OH, the oxygen is going to be produced on the anode unless it's a halide ion. So group 7 ions. Chloride, fluoride, bromide. If those are in the solution, instead of oxygen, it's going to produce that gas, chlorine, fluorine, and bromine. I'm hoping that makes sense. It is a bit complicated with aqueous solutions of electrolysis, but that is kind of the gist of it. So I'm going to reiterate again, with molten compounds, this is combined sciences and triple, molten compounds, it's just simple ionic compounds. So the positive goes to the positive is going to form the metal, negative ions form the non-metal, and that's it. That's the only things you're ever going to form. There's no other thing that could form because there's only those ions in the molten compound. In aqueous solutions, because water breaks down to H and OH minus, you're going to have different things. For the metal, if it's more reactive than hydrogen, hydrogen will be produced. In the non-metal, oxygen will be produced unless it is halide ions. So anything in group 7. I hope that explained that more clear. Okay, within electrolysis, there's also an extra thing you need to know, which is hydrogen fuel cells. This includes both combined and triple. However, combined, the things you need to know is slightly different. I'll just talk about what you need to know for both. So generally, these hydrogen fuel cells, they're supplied by an external source of fuel, and oxygen and air. So it's like hydrogen, and then just the oxygen in the air, in the atmosphere. The fuels oxidize electrochemically within the fuel cell to produce a potential difference. So this produces a voltage. And usually what happens is the hydrogen reacts with the oxygen to produce water, and any excess fuel is going to be reused. And this is a really good alternative to rechargeable cells and batteries because it's very efficient and it only releases water. However, it's very, very expensive. And the reason a lot of us have not been using these hydrogen fuel cells because hydrogen gas is so extremely flammable. So it can be very dangerous and very difficult to store. So the main difference between combined and triple, I just wanted to talk about this first, is that the notes, what you need to understand. Electrolysis, you guys focus more on half equations, reactivity. And for hydrogen fuel cells, you only need to know the simple word equations and compare traditional batteries to hydrogen fuel cells. However, if you are doing triple, you need more detail on basically everything, and your comparison to hydrogen fuel cells are comparing them to normal rechargeable cells. Just wanted to talk about that a little bit. But the general understanding is that fuel cells, they are a good alternative for rechargeable cells, but they're kind of hard to use right now because they're expensive and they're very, very flammable. So yeah, but electrolysis should be done on both combined and triple, but electrolysis, you don't need to know as much. I'm hoping that is clear in the differences. That is it for electrolysis. This was a very hefty topic. Any questions regarding this topic? Because it is quite difficult. Okay, if there are no questions, I'm going to move on. But again, there is a Q&A box that you can feel free to text it. These are a few questions. I do want to have a go at doing some of these. So let's talk through here. 6.4. It tells you that an aqueous sodium chloride solution is electrolyzed in a different industrial process. Two gases and an alkaline solution are produced. So it tells you asking you which two ions are present in the aqueous sodium chloride solution in addition to sodium and chlorine ions, chloride ions. So when it comes to this question, someone asked a question, I'll answer that later. But the two ions are present in the aqueous solutions in addition. So it's asking you what ions are in the solution except for sodium and chloride. So it tells you there, right? It tells you in the question it's an aqueous sodium chloride solution. So you know that there's going to be sodium chloride, so sodium and chloride ions, and there's going to be other ions in there. Because there's water, it's going to be OH and H+. So the OH and H+ are going to be the other ions present. Now it's asking you for the alkali solution produced. This is where we need to think about it more deeply. This links to the next question, actually, asking you why that alkali solution is produced. So I'll explain that. Within electrolysis and aqueous, again, as I've said, if it's more reactive than hydrogen, hydrogen's going to be produced. And if it's a halide ion, halide ions are going to be produced. If that's not the case, oxygen will be produced. In this case, sodium is more reactive than hydrogen. So sodium is not going to be formed, but instead hydrogen. So now we only have sodium ions left in the solution. Now it looks on the other side. Chloride ions are going to be produced because chlorine, that is a halide. Therefore, we're going to produce chlorine. Then we only have OH left. Now that we have only sodium and OH left, add them together, they're going to react, and that's going to produce sodium hydroxide. So hopefully that that's clear. Hopefully that explanation is clear. I know there are a few questions on here. Okay. How do you know whether it is molten or aqueous electrolysis? It does tell you. It does tell you in the question. I highly doubt it they will ask you to figure that on your own. It will tell you in the question, so don't worry about that. Okay. Any questions regarding electrolysis? We're going to move on to the next topic, but that's kind of it for electrolysis I would like to talk about.